Assalamu alaikum everyone. Today's video is on Venn diagrams. Let's start off by defining Venn diagrams. Venn diagrams is a way to organize sets, and sets are a collection of elements. Sounds confusing? Let's try and clarify the situation using an example. So we're going to use a set, which is our universal set, and it's represented by the Greek letter epsilon. And the example we're going to look at is we're going to look at the numbers from 1 to 9. So I'm going to write these numbers down. 1, 2, 3, 4, 5, 6, 7, 8, and 9. These are the numbers I'm going to use in my example. Since these are all the numbers that are going to be in the Venn diagram, they are represented by the universal set. This is the Greek letter epsilon, and it represents the universal set. That's all the numbers in a Venn diagram. Okay. Now, I'm going to further split this up into two sets. I'm going to have set A, which is going to be prime numbers. So in the prime numbers, from these numbers, from the universal set, the prime numbers are going to be the number 2, 3, 5, and 7. There's no more prime numbers. I'll just put this in brackets here. So set A is prime numbers. Okay, so the elements of the universal set, right, were the elements of the universal set were 1, 2, 3, 4, 5, 6, 7, 8, and 9. The elements of set A are going to be 2, 3, 5, 7. Okay. Set B is going to be even numbers. So that's going to be 2, 4, 6, 8, and that's it. So the elements of, let's write this down in brackets so that we know what this stands for, even numbers. You don't need to write this down when you have a set, but I'm just writing it down so that we know what's going on here. So 2, 4, 6, and 8 are the elements of set B. So how does this work out? If we look at set A and set B carefully, right, both of them share one common element, which is the number 2. So if we look at our Venn diagram now, we're going to start filling it up. Firstly, we draw a rectangle over here with two oval shapes or circular shapes, one representing set A and one with set B. In the top left hand corner, I'm going to put in the Greek letter epsilon, okay, to represent the universal set. And as we can see, the number 2 is there in both of these sets. So in the overlap bit, I'm going to start off by putting in the number 2. That's where I would start off. Okay, and we're going to see a little bit later on what we call this bit over here. Right. The next number is the number, well, I'll start filling out the set A now. So set A has the numbers 2, which is 2 is already there, and then 3 can go anywhere here, 5 and 7. And I've filled up my set A. The elements of set A are here, and the elements of set B are 4, 2 is already there, 4, 6, and 8. Okay. Now the next bit is, you see this Venn diagram here, this whole entire diagram is represented by epsilon here, yeah, the universal set. So the numbers 1 and 9 are part of the universal set, but they are not in set A or set B. So they will come on the outside. right? It doesn't have to be at the bottom, it can be at the top, it can be anywhere in the rectangle outside of A and B. Okay. Now, if someone was to ask me, okay, what numbers are in set A, right? So I would write down the numbers 2, 3, 5, 7. However, if someone asks me what is the probability of getting a number in set A, well, I'm looking at 9 numbers in total. And in set A, there are 1, 2, 3, 4 elements. 1, 2, 3, 4. Just 4 elements. So that would be 4 out of 9. And if someone asks me the same thing for set B, the probability of B, right? So again, we got 4 out of 9 because there's only 4 numbers in set B, which is 1, 2, 3, and 4. Yeah. Okay. The next thing is we did say earlier on that we're gonna look at this bit over here. So that overlap has a special name, the shaded part over there. It's called the intersection, right? And the intersection is written as an upside down U or something that looks like an N, right? So that when you see that, that refers to the intersection. The intersection is anything in the overlap bit. So if someone asks me what number is represented by the set A intersection B, so when you're writing numbers in sets, we've got to use these brackets. And there's only one number in there, one element of the set A intersection B, that is 2. Okay. However, if someone asks me the probability of A intersection B, there's only one number in A intersection B, so that's 1 out of 9. Now, another thing we are going to look at is something called a union. Okay, and let's take a step back. For something to be part of the intersection, which is this part here, it has to fulfill both the conditions of A and of B. Yep. A union, however, is slightly different. Yeah, a union looks like a U here. Okay. So whenever you see a U, we're looking at a union, right? And the intersection has to fulfill both conditions at the same time. I like to think of it as the word and. Yeah, it has to be part of A and of B. The union, right, has to fulfill either one condition or the other. So I like to think of it as the word or. So if someone asks me, hang on, what is the set A union B? So again, I'll put those brackets here, and I'm going to write down the elements of this set. Let me shade it in so that you can see what I mean by A union B. It's everything in A, either A or everything in B. Nothing on the outside, although my shading isn't great. So it's either in A or in B. Yep. So that would be all of those numbers. So 2, 3, 4, 5, 6, 7, and 8. Just get rid of the shading, and then there we go. 2, 3, 4, 5, 6, 7, and 8. Those are the elements of A union B. All right. And if someone asks me the probability of A union B, that would be 7 numbers out of the 9. So remember, the union, to be part of the union, you have to either be in set A or in set B. You could be part of either one of them. To be part of the intersection, you have to be in set A as well as set B at the same time. So something that is in both of the sets together at the same time. Okay, so that's the basics of how to fill a Venn diagram. Okay, what we're going to now look at is how to shade a Venn diagram. Okay, and the rest of this video is going to be on shading Venn diagrams, the different possibilities. We'll have a separate video on some Venn diagram questions, but the rest of this video is going to be on shading Venn diagrams. Okay, so here we have the union, which we spoke of earlier, right? So if someone asks you to shade A union B, and you have two sets like that, so you're going to shade everything in A as well as everything in B. Okay. The next one is the intersection, which we looked. So everything, well, not everything in A or B, just the overlap part. Now the union, right? You could be part of A or part of B. It doesn't matter. Yep. Whereas in the intersection, you have to be in the overlap part. So it has to be part of A and it has to be part of B at the same time. And that's very important. So union, it can fulfill either one of the conditions, A or B, and intersection has to fulfill both the conditions A and B at the same time. If you look at this particular diagram, now this one's not labeled on purpose. So the shaded part is just the set A. So this would just represent set A. So we're going to introduce a new concept over here, which is not, as in the word not. So the word not, right, is represented by an apostrophe. So if I was to say not A, that would be written as A with an apostrophe, or something that looks like an apostrophe. And this diagram over here represents not A, because all of the shaded part, everything apart from the set A is shaded. So you've got the entire outside sections shaded, and the crescent of B, which is shaded. The crescent I mean by that is this part here, yeah, which is shaded, not the overlap part, okay? And that represents, this diagram represents not A. Let's have a look at the next diagram. This diagram, as we've seen before, represents A union B, right? Now, what happens if someone asks us to shade in A union B, but not that? So it would be written like this, A union B not, with an apostrophe outside. That's what this would look like. It would be all of the outside shaded, because you're shading everything that is not part of the union. Okay, let's have a look at the next diagram. This is the intersection. A intersection B. So what if we have to shade anything that's not part of the intersection? That would be A intersection B with a bracket and the apostrophe outside. So A intersection B not, or not A intersection B. So that'd be shading everything except for the intersection. Let's have a look at the next one. Okay, so we've got two diagrams here. In the first one, everything is shaded except for A, so this one's not A, which can be written as A with an apostrophe kind of thing. And the second one, only B is shaded, so that's just written as B. So what if someone said, hang on, can you shade the union of these two? So the union of these two will be written as not A union B. Now, since there's a union here, we're going to shade everything that is either not A or it is B. It's very important to understand that because this is the union, right? It can fulfill either the first condition or the second. So to do that, we have this diagram, either not A, which is the entire outside and the crescent of B. Crescent of B would be this bit here, and the pink bit on the outside, or it's B, which is the entire circle of B, or the oval of B. So you're left with this diagram. Yeah, the only bit that is unshaded is the crescent of A. Okay, let's have a look at the next one. So again, we're left with the same two diagrams as earlier on. So this is not A, and this is B. And this time we're going to look at the intersection of the two. So if someone's asked us to shade not A intersection B, so this has to be not A and B at the same time. So you have to fulfill the first condition, which is not A, and you have to fulfill the second condition, which is B, because you're dealing with an intersection. So you got to fulfill both of the conditions or all of the conditions. So that bit will be, this would be here, not A intersection B. This is what it would look like. So just the crescent of B is shaded because anything that is not A will be the crescent of B as well as the outside. But the intersection means that you have to fulfill the condition of it being B. So you have only the crescent of B shaded over here. Okay, we're going to look at the next one. Okay, this is the last diagram. Now we've looked at these two diagrams here. Sorry, the last which we're going to look at. The first one, okay, we could have said that this is the only unshaded part is the intersection. So we can write this as A intersection B, not as in not A intersection B. But we can also write this as not A union not B. How does that work? Well, anything that is not A would be, well, the first condition, not A, would be the crescent of B and everything on the outside. Yep. And then the second condition, which is not B, would be the crescent of A and everything on the outside. Let me try that again. I think I made a mistake there. So not A union not B. So firstly, not A would be the crescent of B, everything on the outside. That's the first condition. The second condition would be not B, which is the crescent of A. That's what we're going to shade, and everything on the outside. And since it's union, we can either shade one of the conditions or the other. So we're going to shade both of them, right? Essentially. So A intersection B not is the same as not A union not B. Now this one, second one, right? Just the union is not shaded, everything on the outside is shaded. So this is basically A union B not. So anything that is not A, or anything that's not A union B basically. And this can also be written as not A and not B. So anything not A intersection not B. So to be part of not A, it would be, let me use this point again. Okay, not A would be the crescent of B at the outside, and not B would be the crescent of A at the outside. But because you have the intersection, you have to fulfill both of them. So it has to be not A and it has to be not B at the same time. So the only bit that is not A and not B at the same time is the outside. Okay. Anyway, that is the end of this particular video, right, on Venn diagrams. So we've looked at how to fill in a simple Venn diagram and see how it works. And we've also looked at the different shadings of the Venn diagrams. Hopefully we'll have another couple of videos or another video on a couple of questions. Thank you for watching. Hopefully this helps. Goodbye for now.